Hello, everybody, and welcome back to another episode or the second episode of this Cartograph series. So, in this episode, we're gonna look at the base workflow and talk about what validation means to Cartograph. Since the whole idea is not just make widgets to port around, but it's to make widgets that pass a validation bar. So, to do this, I will have a demo running in the background while we work, and I will talk about the validation engine. So I want to make a Riemann a integral approximation. This would include Riemann sums, trapezoid, etc. So this, if you imagine like logic that would be important to capture the same every single time, this might be one of them, right? Precision metric. Which would tune the float precision we utilize. So you imagine something like an integral is math logic that you don't want the agent to hallucinate something different every single time. You want to know that when you plug in math to do a left-hand Riemann sum, you are getting a left-hand Riemann sum that you know and love every single time. So we'll let Claude work on that. And I'm going to talk about the validation quick. So when you have Claude make a widget, before it can check that widget into your local registry, it must pass this validation. And so if we look at the pipeline of the validation, the first thing you have is the structure of gets made, the widget, right? And then we run, we take a look at that individual widget and we run it through validation based on the language. I've played around with domain. That might be coming, that's not here yet, but might be coming later to do some domain specific validation. I think there's tiny pieces of it, maybe still in there right now. So these are language checks. So you can imagine a language, wants to ban a certain type of, I don't even know what to call it, but a certain type of implementation. Let's say they upgraded from version 1 to version 2 and they want to have all the version 1 stuff gone. The language validation is, in as many cases as we can cover, positioned to ban the version 1 stuff because we're trying to make it conform to the newest standards that the language demands. So that's what language validation looks like, and then specific paths and ideas that are known to be bad ways to do it, hard coded in here. This is that language floor, and there's a I'm not going to look at the exact code that does that, but in this video, but there is each language has its own specific floor that's tuned, and we'll actually see some of them laid out in this document. It does a contamination scan, which is there API keys in there? Is there URLs in here? We're going to warn about that if it's in the source code, yada yada yada. So that's just two different types of things. One's focused on whether or not the language is written properly. The other one's focused on whether or not you're putting things in there that really shouldn't be included. And then I guess this is a duplicate. I should probably pull that out. And then it does a dependency installation once all that passes. So once we know the widget is a good structural component, then we do things like run the examples, run the tests, get coverage for each language that can do each of those parts. If it can't, we just don't have it do it. So if there's no test coverage in the language, the coverage is not part of the validation. If there's no runnable examples, it's not part of the validation. If you're someone that really wants that for your language and it's not part of it, This is where something like custom rules comes in. So let's say you're using a language that looks like Claude is bugging me here. Example to off at different precision levels. Just wanted to get that going still. Custom rules. So let's say you have a third-party coverage, test coverage tool that you want part of your harness. You would write in your custom rule to send the widget, and the custom rule is the structure that I'll get into at a later episode, but you can essentially take in the same widget structure, and we can use your custom rule to run your validation with your third-party coverage on it for pass, fail, or warning. And then it does a uniqueness check. So if you try to check in something that's identical to something else in the library, I think on the source code and examples, it's going to say we already have this, don't put it back in. So that's just for cleanliness. So that's kind of the order of validation. And we'll take a look at whether this has been booted up. Nope, still working on it. So if we look at what specifically gets checked across all languages, and this, I try to keep it as up to date as possible. It might be a little out of date, but first we're checking, does the widget exist? Is there a widget.json, and is it valid JSON so that the Cartograph can parse it? All those to-do placeholders need to be gone in widget.json, and actually this would be all of them. So all to-do markers across all files need to be gone. Does it have these meta parts to it? Which is, does it have its name? Does it have pulling that up here in a second. Does it have its name? Does it have domain attached? Yada, yada, through the widget.json. Does it have a language? Do all these directories exist? Do they have the files they should? Does it depend on a widget? This one is a big one. If it is importing logic from another widget, it does not pass validation. So widgets are self-contained. There are blueprints if you want to wire them together, and that's a separate thing. But as far as widgets go, they must be individual units. Do all dependencies have version pins? This way we know what version needs to be used. Does the example run cleanly? If it can, this should probably not be in shared checks. Do the test pass, and is it unique? And then coverage, which there's many more languages in here, so I need to obviously update this, but Python is one of the ones that we can enforce coverage, and it's through PyTest. If we look here, there's a couple extra, I see what this was, language-specific validation. So this is a couple other structural parts that need to exist. So the idea is, with Python, do we have this in it, which makes it importable, and is there any print statements in the SRC? Those are things that we want gone, and so we ban it in the pipeline. And each language has its own. I'm not going to go through all this. I will do my best. So it looks like we've got other languages in here. I need to clean this up a little bit, but this is a helpful table down here for understanding what validation looks like for each language. Debug output bans it in the SRC because we don't want that muddying up your debugging. Process exit, sleep blocking calls are banned, absolute paths and string yada yada. So you can dig into this a little bit more, but each language has its own validation that needs to pass, and it has warnings. So there's blocks and there's warnings. A warning lets it through but says, hey, you should look at this, and a block says doesn't let it into your harness at all. So yeah, you can take a look at the validation.md to get a better idea of what's going on in here. And now we have our created widget. So this is doing a numerical integration of a Simpson, looks like cubic method, a couple different methods. It's kind of, I don't know, it's a little hard to understand totally, but this is the ideal, and then this is the, as we change precision, we can see that we get up to 3 correct digits, we get up to 6, we get up to 8, yada yada. So, you know, the logic of the widget is something we tune over time, not the focus of this video. The focus is to now, let me close out of that because Claude's going to want to hold on to that. Oops. There we go. Great. Now, did you validate? It might have up here. I don't, validation passes. So it did validate it. See if there's any case where it did something it shouldn't have. Doesn't look like it. That's okay. So a lot of times the agents will do fine. They understand there's the library notes that they have to read in the widget.json to edit it, explain a lot of the band patterns. And so that gives us a fighting chance. I guess panel A was broken, but that's okay. A little different. Native float, decimal precision, ideal precision. Either which way. Again, not important. I'll look into it another time if I'm curious enough. And Claude's being a little slow here, but it looks good. And we validate and check it in. So once we're happy with what it is, we run it through the validation pipeline. Oh, it did check it in. So it already checked it in for us up here. Yep, it did. So as we can see, it ran the validation, gave us this message that it is valid, and then it was able to check it in to the widget. And it looks like, yes, I think we configured auto publish to be true. I think I went over that last video, but maybe not. So it went up to the cloud registry as well. And that is the workflow of a widget. And now if I want that widget again, I can just search, get a new, and I can cartograph search integration -- Python language Python. And there it is, right there. And there's another one as well sitting on the local for backend account provisioning. But the key thing here is we've got this numerical integration that we can pull. So when we need it, and you can see the relevance score is doing a lot of heavy lifting here. 1.3 to 0.1. This is a good indicator that, hey, this is really what we want. So we now have our integration widget, logic that we can use in later projects and build off of, and continue to validate more and more. So that's the pipeline of what it looks like to get code from idea, need, to creating the widget, to, or having the agent create the widget, to checking it in and making it reusable for your loop, your iteration loop. So thank you everybody for watching that implementation and letting me talk to you about the validation rules a little bit. And I will see everybody in the next episode.